All right, hey guys. Hopefully there's some people here. I think there's four of you in the chat, but if you could type your names so I know who I've actually got today, that'd be good. Yes, this is first online lecture for you lot. It's a repeat of a lecture I did this morning. It should work better because I've had practice at it before. So yeah, we'll see what happens. Just make sure you comment in the chat if there's anything you want me to go over, clarify, or if you want me to stop because I'm going too fast. There is, I think, a 20-second delay though, so bear that in mind. But I'll try and keep an eye on what's going on. All right, so we're going to recap a bit of normal distribution that we did yesterday in class, and then take it a little bit further. So to start with, we've got two different types of variable. We've got discrete variables and we got continuous variables. Both are random in this case. We're going to draw a binomial distribution, which is a discrete distribution, which we looked at the other day, and a continuous random distribution, which is a normal distribution. Okay, there's some key features about the normal distribution. So the center is the mean, and we use the symbol mu. You can draw that a bit better. We use the symbol mu for the mean. There we go. And the points of inflection are at mu plus sigma and mu minus sigma. Remember, sigma is the standard deviation from stats, and mu is our mean. Okay, the two distributions have in common that they both have an area of 1. So area is 1, area is 1. In terms of probability, the area is 1. And we have two parameters for each distribution. So for the discrete distribution, for the binomial distribution, we have n and p as our parameters. N being the number of trials and p being the probability of success. And for the normal distribution, we have mu and sigma are our parameters. Mu being the mean and sigma being the standard deviation. So one we're talking about how number of trials are distributed, and the other one we're talking about how a population of data is distributed. Okay, so in both of them, we write the distribution like this: x approximated by a binomial, n and p. And for normal, x is distributed by a normal distribution, mu and sigma squared. So notice we write sigma squared, not sigma. So what we're actually writing there is the variance. Just bear that in mind that you often have to square root that number or use just sigma and not sigma squared. Cool. Right, a few other key features about the normal distribution. So it is a bell-shaped curve that is symmetrical about the mean. So we said bell-shaped. We've already said there's 2 points of inflection, and that is where we have mu minus sigma and mu plus sigma. So mu plus sigma, mu minus sigma. Oops. And we have asymptotes at each tail. So the probability at each tail, you can see up here, tends towards 0, never actually touches. I've drawn it better on this side. It tends towards 0 without ever actually touching it. So I can draw that a little bit better. Maybe there. Cool. Right, so if we add some detail to this, we've got mu, we've got mu plus sigma at the turning point, kind of there, at the point of inflection, and mu minus sigma at the other point of inflection. And then we've got asymptotes at each tail. Cool. Oh, hey Melissa, just saw you in the chat. Anyone else comment your names just so I can see who's actually in. Cool. Right, so we're going to do some basic kind of calculations with the normal distribution. So I've got a question here for us to try together. So the average number of minutes spent watching one of my videos is 12 minutes. It's not actually, it's way more than that because mine are pretty good videos. And the standard deviation is 4 minutes. So I've written that as a distribution. So you can see here in red, that's the information in the text written as a distribution. We're going to try and find probability x equals 9, probability x is greater than 8, and probability x is less than 4. Hey Molly, just saw you pop up. So to do all these questions, I'd always recommend you start by drawing a distribution curve. It's not a very good one, but whatever. Cool. Right, and we're going to use the calculator for these. We will be doing that for all of our normal questions. To start with them, we need to talk about this one. So probability x equals 9. Now, because, as I said a few slides ago, I think back at the beginning, we've got a continuous variable. It means that our variable can take any value within a given range. So the probability of actually getting 9, imagine if you guys all kind of stop watching my videos at some point, the probability of it exactly being 9 seconds, given that we've got milliseconds, nanoseconds, microseconds, whatever, the probability of it being exactly 9 is like 1 out of 100 billion, basically infinite different lengths of time that you could be watching the videos for. So the probability of actually getting 9 is 1 out of infinity, so we round it to 0. So the probability that actually equals 9 is 0. And I can show you that on the calculator. So if I bring up this calculator, if you go to statistics mode, get out of this, go to distribution, which is F5, normal. So we're trying to look for 9. I'm going to go from 8.99999 up to 9. So I'm trying to approximate as close as I can something that will round to 9. I guess I could make that 9.000001. We'll put in our mean, which was, our standard deviation, which is going to be 4 because standard deviation squared, remember that bit there is sigma squared. Can you see the squared there? Sigma squared, just about. So I need to put 4 in for that one, and my mean is 12. So I'm going to put 12 in there. Cool. Right, so the graphical calculator is quite good because it can actually draw these. So if I draw that, it will sketch me my normal curve. And you can barely see it. If I make the calculator a bit bigger, you can kind of see it's drawn a line there. That's the line where x equals 9. And you can see my probability is 1.5 times 10 to the minus 10, which is absolutely tiny. So we're going to round it to 0. So with our normal distribution, if it ever asks you for the probability of getting a value, whatever it is, the probability is always 0 for that value because it's a continuous variable. Cool. All right. The other one's a bit more standard. So we're going to do the x is greater than 8. X is greater than 8 next, and we're going to sketch that. So if I put a line here, kind of cordon that one off. So draw my sketch. Oh, hey, Jasmine and Jack, Grace, and Elizabeth. Thank you for watching, guys. I'm inside the distribution. That's always good. So the mean was 12. So I'm going to label that here. We're trying to find the probability x is greater than 8. So if I put 8 here, we're trying to basically find all of this probability. Maybe I should move. Yeah, let's get out of the way. Cool. All right. So as we said, the whole distribution, the whole curve had a probability of 1. Half of the curve, so this bit here from the mean upwards, should have probability of 0.5. So we're hoping our answer should be a bit more than 0.5. So let's give it a go on the calculator. And you can do this on the graphical or on the class whiz. I'm going to use graphical just because you can see the sketch, which is quite nice. So I'm going to go back. We've got the same data as before, so we want greater than 8 this time. So 8 is going to be my lowest value. My upper value, just put in something big. So let's go for 3000. And sigma is the same, mu is the same. Sketch it. There you go. My sketch was pretty good actually. If you look, they're pretty much the same. So you barely read it there, but the probability says it's 0.8413. 0.8413. And we always go to 4 decimal places. Reason being, that's what the old school statistical tables used to go to before we had graphical calculators. So yeah, 4 decimal places for all the normal distribution stuff. Okay, I'll do the next one and then I'll show you how this works on the class Wiz. So we want x is less than 4 this time if I move my calculator a bit. So let's do another. Oh, I can use a sketch up here, can't I? So we had 12 was the middle value. We want x is less than 4. So we're looking for this shaded area here. So it's going to be something less than a half this time, because as you can see, we're taking up less than half of our area. So back on the calculator again, and we're going to go from lower of 0 to an upper of 4. And draw it. And you can see it's barely shaded in anything, so our probability, if you can see it, 0.0214. Okay, let's move the calculator. 0.214. Cool. Right, so I'm going to try and do the same thing, but with the class Wiz calculator, because I know some of you guys are using that one. So, and this should hopefully work. Here we go, here's our calculator. So, this flappy thing's always in the way. Alright, so if you go to menu, distribution, same place you find your binomial stuff, and we're going to go to normal CD. Now, there's no point doing normal PD because percentage, as we said, rounds to 0. So we're never going to use that. We're going to use normal CD. So 2. So I've actually forgotten what the question was for this one. Our lower, so we'll do the last one we did. I think the lower was 0 because we're going from 0 to 4. Let's try and focus that a bit better. Upper was 4. Sigma was also 4. Mu was 12. So it's pretty straightforward, really. Hit the answer 0.21 and 0.0214, which is the same as what we got earlier. So that's how you do it on the class Wiz. So class Wiz, in that respect, absolutely fine. It doesn't plot it, but it gives you the right answer. Good. Okay, what we do next? Yeah, cool. So that's normal distribution, and that's normally how that's how we're going to try and work out what these probabilities are. However, there is another way of doing things, and this one requires a nice big sketch. So if you guys could sketch this in your notes, I would take up quite a bit of room, half a page with this one. I'm going to put the mean in again. Maybe we can do a better job than that. Going to put the mean in again. Okay, now, between the two mu minus sigma and mu plus sigma lies 68% of the data. So between these 2 points lies 68% of your data. And you are expected to know that. So mu plus sigma between, well, basically within 1 sigma of mu is 68% of your data. So 68% in here. Yep. Within 2 standard deviations. So let's try and draw that on here as well. Whatever. Mu plus 2 sigma and mu minus 2 sigma. Between those two, we have what was it again? 95% of the data. And finally, from mu minus 3 sigma to mu plus 3 sigma. Is that coming on screen? Yeah, good. We have 99.7% of your data. And they're not random numbers, those are based on standard deviations. So it's likely standard deviation, remember, is a measure of the spread of the data. Most of your data is within 3 standard deviations looking at spread. So have a quick think, try and work out what's left in each case. So 99.7%, you're going to have 0.3% split between either bit. So you'd have 0.15 on this side, 0.15 on this side. For the 95%, you've got 5% split between each tail, 2.5, 2.5. And for 68, you've got 32% split between each tail, so you've got 16 and 16 per tail. Cool. All right, having said that, most of the questions they'll ask you about this, you could probably do just using the calculator. But if you can remember those 3 numbers, it can be a lot quicker and easier to solve these types of question. So we're going to try a question about pigs. So the masses of pigs on a farm are modeled with this normal distribution. We've got an unknown mu and an unknown sigma. They say if 80% of the pigs weigh more than 52 and 97.5% of pigs weigh more than 47.5, find mu and sigma. So because we've got 2 unknowns, we're going to have something to do with simultaneous equations. So I'm just going to adjust my mic because it's feeding back a bit there. We're going to go, let's write the details down that we've got so far. So I know that 84% are greater than 52, and I know that 97.5% are greater than 47.5. Right, still kind of difficult to know what to do, so we're going to draw these on a normal distribution sketch. Okay, so for the one on the left, if 84% are bigger than this, are bigger than 52, where is 52 going to go on our normal distribution curve? So 84% are bigger than this. Remember, the whole area is 1. So because 84% are bigger than it, we must have 84% in this region of the graph. So 52 must be to the left of the mean. So I can write 52 in there. And we can write, well, let's write percentages even. Let's write 84% in there. Everyone happy with that? It's got to be 84 because obviously 50% would be halfway and we've got more than 50%. Okay, for the other one then, we've now got 97.5% is greater than 47.5. So again, it's going to have the same idea. More of the data is going to be to the right, even more. So our 47.5 is going to be even further below, which kind of makes sense because if this one 52 is over there, what am I doing? 52 is over there, 47 must be even further that way. So 47.5 and 97.5 of the data there. Okay, so the key to this question is what we were talking about on the last slide. And it's to do with how much is left in each bit. So if we go back, if we think about what's left over, so if 97.5% is greater than 47.5, it means that 2.5% is less than it. And for the other one, if 84% is greater than this value, it means that 16% is less than it. And those 2 numbers should ring a bell because we talked about those just now. So if I flick back again to the other slide, remember with 68, we had 32% split for each tail. So if you split that, you get 16% for this tail and 16% for the other tail. 16%, well, that's the same thing we've got in our first example over here. Okay, if we go back again, I'm running out of colors here. We've got gray. Cool. 95%, so for 95, it means there are 5% split for each tail, which will be 2.5% per tail. So right in the corner here, over here, that is 2.5% again, which links up with our 2.5% over here. So I then know basically that 52 in the first example is the same as, if we look at our first example, 16%, that was the yellow one, so that is mu minus sigma. So I can say 52 equals mu take sigma. And the 2.5% in this one links up with the grey there, 2.5%, which came from mu minus 2 sigma. So if we go back, I know this is mu. Cool. So we're left with two equations with two unknowns, so we're going to solve them simultaneously. Because we've got just one mu in each, if I subtract those two, it should all work out nicely. So I'm going to do this one, take away this one. So 52 take 47 leaves me with 4.5. Mu take mu, 0. And minus mu minus minus 2 mu is going to be minus, a minus, a minus. So we'll end up with equals sigma. So we found sigma. The question actually asks for mu and sigma squared, so I'm going to square that. If I square that, I get sigma squared is 56.5. No, it's not. That's rubbish. It's 20.25. And I can use sigma to find mu. If I put sigma back into this equation here, if I put 4.5 into there, I add 4.5 to the other side and get 56.5. So mu is 56.5. Sweet, done. Right, I'd pause that and have a look through it. I'd flick back through the for your notes, because it's, before you can remember 16 and 2.5%, it is a bit kind of new. Okay, so that's the pigs question done. What's next? So okay, so that was a weird question. We're going to do one now that you can just relax, rely on the calculator, and it's a lot easier. So let me bring the calculator back up. Cool. Right, so example number 2. Cool. All right, so we're going to do y is a variable modeled by a normal distribution with a mean of 45 and a variance of 4, or a standard deviation of 2. Remember, that's sigma squared. Okay, and I'm going to ask you guys two questions. One of them we're going to do together, and then you guys are going to have a go at trying the second one. So the first one, part A, is find the probability that y is less than 41 or y is greater than 47. So all good questions start with a sketch. All good answers, I should say, start with a sketch. So draw myself a normal curve. Cool. Put in the mean. So the mean is 45. And we're looking for y being less than 41. So if I draw 41 on here and shade that area that we're trying to find, we want to find this probability. We want to find this area here. Or y is more than 47. So if I put 47 in there, shade that as well. So we're trying to find those shaded areas. There's a couple ways we could do this. There's one slightly easy way, one slightly harder way. So not slightly hard, slightly longer. The longer way would be to work out the probability that it's less than 41, then work out the probability it's more than 47, and add both those together. And that would work, but you're wasting time doing two different sums. What we can do to make things a little bit easier is we can work out the area in the middle. Let's position myself here. So if we work out this middle area, take it away from 1, which is the whole thing, we can find our two little edge bits. So if we do 1 minus the probability that y is greater than 41, less than 47, we can work it out. So let's bring up the calculator. Depending on which calculator I think you've already seen this now. So if we go menu, oh, I'm clicking the wrong thing. If we go back to distribution, normal distribution, NCD, our lower bound is 41 and our upper bound is going to be 47. So lower 41, upper 47. Standard deviation is 2. Oh, what have I done? Yeah, standard deviation is 2, not 4. And our sigma is, so our mu is 45. So I type those in, do a sketch just so we can be sure we've done the right thing. That looks good to me. And it's giving me the answer as 0.8186. So remember 4 decimal places. 0.8186. But I need to take that away from 1. So let's get rid of the box I just drew. So we're going to do 1 minus this value. 1 take this. And you might remember the easy, quick way I told you guys to do this last year. Remember, we need to make every digit add up to 9. So to make the 8 add up to 9, we're going to get 1 as part of our answer, or 0.1. To make the 1 add up to 9, we're going to get 8. To make the 8 add up to 9, we're going to get 1. And then the last digit we make add up to 10, so we need a 4. So 1 minus that equals 0.814. So that's our answer. Cool. Right, you guys ready to try one? So let's just hide that calculator. I'll give you guys a sec actually to copy this down. So if you want to copy that for a sec. Cool, and let's rub it out. So this is part B. We're going to do probability that y is less than 44 or between 46.5 and 47.5. Cool. Could you guys give that a go? Don't forget to sketch it. I think we'll say 3 minutes, I reckon, on this one. So there you go. 3 minutes. Let's see how you get on. I'll be back in 3 minutes time. Oh, and if you need any help, type it in the answers. Type it in the comments. And if you get a correct answer, type it in the comments and we'll see who wins at getting the first correct answer. All right, time's up, guys. Um, I didn't see any comments of any answers. Don't be shy, guys. Please do some commenting if you need help or if you get a correct answer. Um, but yeah, let's go through this then. So where am I? Let's bring me back. There we are. Cool. Okay, so if we sketch this, sketch again, most important thing with these questions. I know the mean is at 45, and we want less than 44. So we want all this area. Now we want 46.5 to 47.5. All right, calculators are good, but they can't find two separate regions. So we have to do this in two different parts. So we're going to do less than 44, and we're going to do between 46.5 and 47.5. So let's bring back the calculator, and let's do the lower region first. So we want lower to be 0, upper to be 41. Sigma is still 2, mu is still 45. Sketch it to make sure. Yep, looks about right. So we got 0.0228 because we need to round that. 0.0228. So that's that region. Okay, and let's do it again with the upper region. So we're now going from 46.5. And this would be exactly the same on the class Weds, just without the sketch. Where it says save res, that's save residual, so that it saves all the data points. Don't worry about that. Cool. Execute. Draw it again. Good. So we get 0. What's that? 121, I guess. So need to add both of those probabilities together. So we're going to get 0.1438. Yes, I believe. Wait, is that right? Let me just double check that because I think I got a different answer when I did this earlier. The top one's right. I'm worried about that second one. Lower 0, upper 44. Yeah, I thought that was wrong. Cool. Sorry, guys. Get rid of that one. That should say, and get rid of that answer. I don't know what I typed in then. That should say 0.3085. So add those together, and we get 0.4295. And that's the answer I've got written down on my sheet, so we're probably correct this time. Cool. Okay. Right, we're going to try another question now. Actually, does anyone need time to copy? Anyone need time to copy that? No. Cool. Right, we're going to try another question. This one's pretty tricky. I'm again going to give you guys a bit of time to do this. I think 5 minutes should be fair. It's worth 5 marks. First one, part A, super easy. Part B, however, is a mix of binomial and normal. So sketch it. You need to work out the binomial again for part B. Sorry, you need to work out the normal again for part B, and then you're going to mix it with the binomial stuff that we did last year and then we did a bit of yesterday. So give that a go. 6 minutes on the timer. There we go. Again, comment if you need help, and comment a correct answer if you. Oh, well, the answers are there, so maybe don't do that. But comment if you need any help. Damn, I forgot to unmute the mic. Sorry. Thank you, Molly. I'd totally missed that. Okay. Well, you guys probably saw what I was doing. Um, yeah. Anyway, we've got we've got the random sample now, so we're looking at binomial distribution. So x is now binomial. We've got a sample size 30 and a probability of we need to work out the probability. So we put p there for probability. Okay, find the probability at least 15 of the squirrels have a mass between 470 and 490. So you want to try and find the probability that x is greater than or equal to 15. Problem is, we don't know the probability. This is what we're looking for, the probability that they're between 470 and 490. So if you like, you got to think first, we need to do some normal stuff. So you want to find the probability x. Probability x is between 470 and 490. Which is a normal question. So this part is normal, which we need to do this part, which is binomial. Okay, so to do that, we've already worked out, if we look back at part A, because it's only 4 marks, so we can expect something's going to be valid from part A still. If we look back at part A, we wanted to try and find the mass greater than 490. So we found greater than 490 was 0.4013. So if I do a quick sketch of what we've done, we know 480 was here. We found greater than 490 was this bit. So we found this was 0.4013. And we're trying to find 470. Now, if you look at these, you'll see that it's symmetrical. So just put myself in it. So we can see 490 and 470 are actually equidistant from the mean at 480. So I actually know that this area is the same as this area. So I can work out this probability relatively easily because both these bits are going to be 0.4103. So without grabbing a calculator, I can say, well, let's add these up. 0.8026. Cool, let's write it down. So the middle bit, and we can do that thing again when we make each digit up to 9 and then the last digit 10. The middle bit is going to be 0.1974. So that is the probability the squirrel has a mass between 470 and 490, and that is the probability that we need for our binomial. So this is much easier, is this probability which we are using for the binomial part of the question. So let's erase all this. Hopefully you guys have had enough time to copy all of that down. Rub out all this bit. We'll use that in there, and then we can do the binomial part of the question. Cool, nice. So there we go. So now we got just a standard, I almost said normal then, we've got a standard binomial question. We're looking for the probability x is greater than or equal to 15 with those probabilities. Remember on a class whiz, you have to do 1 minus. So if you're using a class whiz, you're going to say that's equal to 1 minus the probability x is less than or equal to 14, because remember, binomial distribution is discrete. So if that's 15, we want all this stuff. We need to do 1, which is the whole area. 1, which is the whole area. Take away these bits, which is 14 and down. So 14, 13, etc. So that's what I need to take away. If you've got the graphical calculator, and I'll show you that one, we can go to statistics, distribution, binomial distribution, We want to find the value. We know the probability, so it's going to be a B, C, D question. Lower bound is going to be 15 because we want it to be greater than 15. Ooh, 15. Upper bound, well, how many squirrels we got? We got 30, so upper it's going to be is 30. Number of trials, 30. Probability of success, this is what I did earlier today, 0.1974. So it's all kind of set up there for me. Cool. Scroll down, hit execute, and there's our answer. So let's write that in. 0.1986, but I need to put a lot more noughts in there because I just realized it's to the power 10 to minus 4. So 0.000019. 1986. Cool. Brilliant. So that's our probability. Which is what I had written down at the top anyway. Good. Cool. Hopefully you guys are all alright with that. I'm going to wait a sec just to see if you got any questions. Let's hide the calculator again. There you go. Has anybody got any questions? There's a 30-second lag, so I'm going to be quiet for 30 seconds while I wait and see if you have any things you want to know. No, it doesn't look like you do. So I'm going to assume that you guys are smashing it. You got that right anyway, and you're just waiting for me to go through it, hopefully. Okay. Yeah, good. Okay, so that's the basics of normal distribution. How long we got left? 20-ish minutes. Good, we're doing well for time. Okay, so we're going to move on now to the inverse normal distribution. Still normal, but working backwards. So instead of having the probability, instead of knowing the value and trying to find the area, trying to find the probability, we're now going to know the area and be trying to find the value of A or X or whatever our variable is. So using the area, remember area's probability, to find the cool. So in other words, we know probability X is less than A equals, and we probably know the probability, I don't know, 0.4. Actually, let's do 0.75. So this is a inverse normal style question. So again, sketch it. It's a good way to start these kind of questions. So we're going to draw our sketch. Now the mean's going to be in the middle. If our area is 0.75, where's it going to be? So remember 0.5 is each side is 0.5. So if it's 0.75, it's going to be, we're looking for less than this is 0.75. A must be here for all of this area to be 0.75. So let's draw that in. So that's the bit that we are trying to work out. Okay, anyway, here's one I made up earlier. So here's 3 questions. I'm going to show you guys how to do the first 2, I think, and then I'll let you guys try the third one. So as I said, draw it for each one of these. So if I put myself up at the top for these, cool. All right, so we're going to draw each one of these. So first one, as I drew on the last screen, there's A, 0.75. So also A must be a number more than 20. Our distribution has a mean of 20, spread of 3. A has to be a number greater than 20. So we're going to get the calculator back up, and I'll show you guys this on the class whiz and on the graphical. One important thing to remember about or to know about the class whiz is the class whiz is less than only. Same as with binomial, class whiz only does less than or equal to. For normal, class whiz only does inverse normal, less than only. So that's going to be something you have to factor into your workings. Graphical calculator can do whatever. So yeah, but you might want to show full workings anyway, so you don't risk any method marks. So make sure you write that down if you're intending on using the class whiz for these. Okay, so get my calculator up. Oh, we're doing. Get the calculator up and move everything else. Okay, calculator is up, and we're going to go now to distribution, normal, invn, which is inverse normal. And it's going to ask us some weird questions. So first thing it's asking us is where the tail is. So the tail is referring to, on our graph, these bits at the edge. This is one tail, this is the other tail. So our area, if you imagine we had a shaded area, our tail is to the left. So we're going to say left on the calculator. Now what's the area? Remember, area is probability, so 0.75 is our area. Sigma, standard deviation, we know is 3, and mu is 20. So type all that in. It doesn't draw it this time, which is a shame. Hit calculate, and the answer is 22. So A equals 22.02. Okay, let's quickly go through how you would do that on the class whiz. So I happen to have a class whiz. Cool. Is that working? No. Yes. Cool. Right. Menu. Cool. Sorry, it's very laggy this. Distribution. Inverse normal. And it just asks you for area, sigma, and mu. So whereas on the other one, it asked me if can I bring the other one back? Yeah, I can. So on the graphical, it asked me for tail, area, mu, and sigma. For this one, it doesn't say tail because it's always assuming it's a left-handed tail. So for this question, it doesn't matter. We can just put 0.75 in. Oh, I'm typing into the wrong calculator. 0.75, 3, and 20. It equals, and we get the same. Wait, what? Do that again. Oh, I typed in 20. There we go, 22.02. So you get the same area. But yeah, just bear in mind this only does left-handed tails. Cool. Which is fine for a question like that, but for the next couple questions, it's a bit harder. All right, so for this second question, if I just hide the calculator for a sketch again. There you go. If I sketch it again, this time we're saying the probability x is greater than a is equal to 0.4. If I stop moving the screen. Okay, so the probability it's greater than this value is less than 0.4. So if 0.5 is here, if the probability it's greater than it is less than 0.4, it must be about here, making this probability 0.4. So it's right in A, and this bit 0.4. So on the graphical, nice and easy. Bring it up, move it somewhere. Sorry guys, this is not going as well today. Move the calculator out of the way. There we go. That will do. So if we go back to distribution, normal, inverse normal, we can just say, well, the tail's to the right now, which is where it is here. So choose right. Again, we've got area of 0.4. Everything else is the same because it's the same question. Scroll down, execute, answer 20.76. So nice and easy with the graphical. Okay, with the class Weds, because the class Weds only does less thans, we have to work out how to turn this into a less than question. It's not actually that hard. So the greater than a probability is 0.4. Therefore, the less than a probability, this bit that I'm inside right now, is going to be 0.6 because it has that up to 1. So we can put 0.6 in there, and then you could do that on the class Wiz. You could type in 0.6. Everything else is the same as before. Hit equals, and you'll get the same answer. Hopefully that makes sense. Please comment if you want me to go over that in more detail or do it. I've got the calculator here, but I'm a bit conscious of time because we only got 15 minutes left. Okay, how are we actually doing for time? Pretty good actually. All right, I'm gonna give you guys 3 minutes to try and do this last one. This one. Can you do a sketch and give it a go either on the class Viz or the other one? It is a bit more tricky, but yeah, should be right. Try a sketch and see how you get on. So 3 minutes on the timer, starting from now. And let's bring up the timer. There we go. Cool. See you in 3 minutes, and I will leave the mic unmuted this time. Cool. Right. Again, no comments. Hopefully you guys did right with that. So let's go through this one. So I'm going to get rid of everything else, make some space. So I want to draw a nice big graph for this one. And we're doing it right for time, but I'm a little bit rushed, so let's get away through this. Okay, so 20 in the middle. We're looking for the probability is between 16 and A. Where's A? Who knows? A might be here. It might be here. Doesn't matter. Not really. Probability is between those two things is 0.3. So I'm just going to pretend it's the second option. I don't think it is, but whatever. Gives you a room. I'm going to say that's 0.3. So, not sure how you guys might try this, but I think the easiest way is to find out what this probability is, and then we can use the whole of, when I found out that bit of probability, we can use the whole of this as the probability inverse to find A. So, first bit is use a standard normal function, not the inverse one, to find out what that probability is, add that to 0.3, and then we can find A. So let's bring back the calculator. Come on, calculator. There you go. Cool. Gotta stop moving things around. Okay, so we're going to do a normal distribution without the inverse. Lower is going to be 0. Upper is going to be 16. Mu is 3. No, sigma is 3. Mu is 20. Draw it. There we go. So that's the area there, which is 0.091. So let's draw that in blue. 0.09112. So we know that the probability x is less than a is now equal to those two things added together. Oh, let's hide the calculator. Less than a is equal to those two bits added together. So 0.3912. I can now put that. Oh, what am I doing? This is terrible, isn't it? Sorry, Jack. Sorry, guys. Yeah, so I worked out the bit to the left of 16 because we know 16, we can use a standard normal function to find that. So we did that, worked it out 0.0912. Then we're going to use that with the probability 0.3 to work out what A is with an inverse function. So we're going to go back into the calculator. This time we're looking at inverse normal because we know the probability. The tail is to the left, so you can do this straight away on a class whiz. Area 0.3912. Mu is 3. Sorry, sigma is 3. Mu is 20. Calculate. And we should get 19.171. So yeah, I did draw A in the wrong place. Let's just move this calculator out of the way. Yeah, I put A in the wrong place, so we could correct the sketch if I really wanted to. Put A here, because that's a probability of 0.3. But it doesn't really matter. We got the answer right. And we didn't know where it was, in fairness. Okay, so I'd like you guys to do a bit of practice on this before Friday, because obviously we're going to move on Friday, and the more practice you've done, the better prepared you will be. Oh, let's just make a new page. So between now and Friday, if you... Oh yeah, I wanted to do that for Elizabeth in a minute, because she wanted me to go through that. So I will do another question in a sec. If you guys have got to go get buses, you can in a second. There's just a couple bits I wanted to say first. So yeah, before Friday, if you could do page 46, 7, 8, and 9, that would be fantastic. Remember, the solutions are all on the Edexcel solution bank. There's no C in Excel, or is there? I think there is. I work for them, I should know. Edexcel solution. I'm tired, I can't remember. Edexcel solution bank. Google it, and you'll be able to find the work solutions to those 3 questions. Answers are in the back of the book. Remember, you guys know where to get textbooks from. Yeah, the last thing is, so I think college is shutting for students next week. There won't be any online lessons until Wednesday for most subjects. I think I'm going to keep going and do Monday and Tuesday and Wednesday as normal. So your lecture for you guys will be Tuesday last lecture. I will be doing it live at that point. If you're not there for some reason, it'll be uploaded afterwards. Same with it. This lecture will be online afterwards. There'll also be this morning's version of this lecture online afterwards. And I'll be repeating this lecture tomorrow morning at 11 o'clock as well, with the mic down and unmuted. Hopefully, I think that's going to be a regular problem. Yeah, the other plan is eventually, probably towards the last, it won't be on Friday's lecture, but towards the end of the week, in future weeks, I think we'll use Microsoft Teams to have a group chat, and we can just have like a little seminar talking about things in person, because obviously I can't actually hear you guys. It'd be good to touch base on things, basically. So yeah, that's it for today. Please email me and let me know how you think that went, whether it was good, what I could improve, if I need to slow down, if there's anything I can make clearer. Give me feedback, because this is the first time I've ever had to do this as well. So please let me know about that. Um, Also email me if you're stuck on anything. Yeah, so that's it for today. I'm going to go through one more question, because Elizabeth emailed me earlier with a similar to the question we did about pigs earlier on. I'm going to go through it now. So there's 4 minutes left. If you want to stick around, you can. Um, but otherwise, I will speak to you guys on Friday, and don't be shy about getting in contact in the meantime. Cheers. Thank you. All right. So I've got my workings here, so I need to clear all this off. Oop, deleted mu. So yeah, this is a similar question to the pigs question that we did earlier, when you need to know all the probabilities. So I'm going to put mu in here. Okay, so we've got the weights of a group of dormice. D is modeled by that normal distribution. And we're told if 97.5% weigh less than 70 grams, find the mean. So let's do a sketch. So mean is there, we don't know what it is, but we do know 97.5% of these 97.5% of these mice weigh less than 70. So that tells me 70 needs to be on this part of the graph. 70 grams. Cool. And it tells me this area here, 97.5%. It also tells me that this bit of area here is going to be 2.5%. Now, hopefully that's ringing some bells. It might not be, but we'll see. So if I flick all the way back to that slide from earlier, God, my work is very messy, isn't it? Here we go. So 2.5%, which is there in grey. We did it earlier. Where's it gone? That way. That way. There it is, 2.5%. So if you remember, that one links up with the 95% in blue, which links up with the mu minus 2 sigma. So with the dormice, I think we have 2.5% here above our dormouse weight of 75. So it's basically telling me 75 is mu plus 2 sigma. So if we go all the way back to that slide. Oh no, I hope I've not broken it. Oh, good. Okay. There we go. I know that 70 equals mu plus 2 sigma. And we know what sigma is because they told us. Sigma squared is 25, therefore sigma is 5. Because obviously that's sigma squared. That there is sigma squared, so therefore sigma is 5. So 70 equals mu plus 2 lots of 5. In other words, sigma is mu plus 10. Oop, close brackets, 10. So mu equals 60. And that is how you do that one. There is another method for this, which we're going to look at on Friday, which is going to be finding other unknowns in the normal distribution. But that's how you would do this one. So please email me if you have other questions you're stuck on, and I will just tag them on the end of our lecture, because we kind of have infinite time now, which is amazing. So yeah, keep well, guys. I don't know when I'll see you next, to be honest. Who knows how long this thing will last for. Hopefully we'll have a video call probably next Friday before half term would be good, before Easter would be good. And I'll probably be running, because there's nothing else to do, probably running some mechanics, statistics, pure revision over Easter, because I may as well, really. So yeah, let me know if there's anything I can help with, and thank you. Like, share, and subscribe.